eerste is een kort filmpje laten zien wat een impressie geeft van hetgeen er binnen onze faculteit speelt.
Electrical engineering is trying to find answers.
Ja, daar komt ja.
Can we develop smart grids where we use electric cars to store electrical power? Can we use ultrasound to diagnose cancer? Can we use optical chips to increase the data rate of internet to 10 Gbps? Important societal challenges to which the Department of Electrical Engineering is trying to find answers.
Electrical engineering is all about solving problems and challenge needs.
The field embraces both analog and digital systems in which hardware and software are equally important.
You see the process of from small parts to a complete machine, and you are learning something. That's the most important thing.
Well, the problems you're confronted with are often quite difficult, and it's often a struggle to get into it and to get things work. So you put a lot of effort in it, but in the end, when it really works, that is really cool to see, and it gives you a lot of satisfaction.
For instance, with the solar team, we made the first family car that's powered by solar energy. That's really the world's first.
Putting theories into practice to develop your expertise. That's what we believe in. In design-based learning projects, you learn how to solve problems independently or in small groups.
It's rather easy to put the theory into practice here. The assignments and projects that you work on are based around subjects that are really relevant to society.
I believe this is the age of electrical engineers, and it's going to be for a long time now. So I want to be right in the middle of it, and I want to be one step ahead of everyone else.
The past 50 years, electrical engineering has radically changed society. No other discipline had such an impact. During the next 50 years, an even greater change is expected. With larger connected systems and increasing complexity, the demand for skilled electrical engineers is still growing.
The region Eindhoven is great. There are a lot of opportunities, a lot of cool companies that are really very close by.
This region is just where everything happens. It's like the Silicon Valley of Europe. So if you're right in the middle of it, you have access to everything.
Eindhoven University of Technology is established in Brainport, the high-tech region of the Netherlands, one of the most
I have the day after one period of working, also a big moment now, after one period of hearing all kinds of talks, half of them you can't understand because it's completely Dutch. Okay, so first some background, so you are from India, people will recognize it, I think, you did already your bachelor far away from your home. India is a very big country, but even then you decided to go even further away and choose for the Netherlands, and then choose for our university and to do your final work in our group, Big Signal Microelectronics Group, where we make, let's say, the electronics that take very small signals, make them robust, filter them, and then convert them to digital. My first experience was before your final work, was in the course I gave, ADA converters, and you came in doing your exam, and that result of the exam was not completely what you expected. And then we had a talk about not just about the contest, but what about how to learn the contest, learning how to learn. And I was really impressed by the intensity that you were listening then. And I think, I don't remember exactly, 2 or 3 weeks later, you came back, you did the same exam, and it was a very high mark then. I was really impressed. I have never seen so much increase in learning. That also, I was enthusiastic that you also came to the group, and I was really willing to help you, of course. Mostly I do the talk here, and the people in the group are doing the supervising, that should be said very easily. course, you like Philips very much because you went 3 times. One for the first internship via the other group, the signal processing group, for LEDs, lighting. And then you did your second internship with our group, that was for piezo sensors. And then finally you worked on your master work. All the works I will discuss more about your master works in a minute, but you did all Philips with very good results. So it's we are very glad to see you here. Now, before I go into detail, some detail about the rework, I would also focus on how you decided to get that project and how to define the project. Well, you are a guy who's taking a lot of initiatives, very much initiative, sometimes somewhat too much. So, one person you are discussing a final work, then with parallel with another guy you are doing the same, then you are going to 3 businesses and you have discussions, etc. And finally, we have to do the work to finally define, well, what shall it be and how can we tune it? It says something about you, and finally Peter Harper became your supervisor, and I said Rosenhoff at Philips. Now about the project, well, the title, as you have seen, is Low Power 12-bit SAR ADC for 3D ultrasound. The last may be well known to some people here, and there was already something said about ultrasound. You know that from an echoscopy of a baby in the womb of a mother. You can make images, although you can't directly see it, but you can photographs with light. You can also take photographs with sound. You expose sound to it, and you take it back, and you take a very highly sensitive array of sensors, and by focusing that on successively on many points in the body in this case, but you can do it for different applications, you can make really 3D pictures, very good 3D pictures of the baby. But of course, well, you have to do the application as was discussed in another final work, but you also have to really make the hardware for that, and that means you have to take up this very small signals which come back from a mother. You have to detect them to get rid of noise, etc., and then to combine them. And of course, somewhere you make the decision to make it digital. Part of the job was, where do we make it digital? Because you have thousands of those pixels, and you can do it at every pixel. Then you need thousands of AD converters. You can do it completely at the end. Well, those are not the most optimum normally, so somewhere in between, in the middle. That was the first part of your design work, to see, well, what is the best in this situation. And we are talking here about 3D ultrasound for, let's say, more mobile applications, for home applications also, so the size and the power dissipation are also important, especially also the size. So the result of that was decided by so many pixels per AD converter, etc., and I will not go into further detail there. But then the next question is, which kind of AD converter? Because there are a lot of types of AD converters. 2 mainly are potential candidates, very good potential candidates, what we call the sigma delta and successive approximation converters. And what is the best? Well, you cannot answer that. That depends on the application. What are the best? What are the trade-offs you have to make? That depends on the specs. And this application, you really investigated that thoroughly, and you came out with the conclusion that the SAR is the best in this case, having especially the size aspects into mind. Then the third step in your design was, no, really make it. Because now you have decided what to do, now you have to do it. And that was based on the first design of Peter Harper. You had already made some architecture, you really designed it further on, you elaborated on it, and you made a real SAR converter for application in such a complex system. So, that is what I want to say about the work, because if I say more details, I don't think that makes much sense. You will understand that you don't, of course. So let me say now some things about the person, about Ashwin himself. I've already said he's very, very motivated and also has a very broad interest, and things go often together. That means also very hard working, but it also means going very, very, very fast. And that's not always the best way. If you are in a car, it was talked about vehicles, if you're a car on the roadway, you drive too fast, you might pass the crossing and then you have something you could still improve in the future, but of course it's due to a very high motivation and a very broad interest, and that's very, very good. You're also very, very convincing in the way you are talking, in the way you are doing, not only what I mentioned about the definition of your work, but I also learned from Satir that when he was at Philips, well, Philips is a big business. I think it's still a big business, but every big business has its bureaucracy, and you know to handle that very, very good. And I've heard the secretaries, well, instead of hearing all the way how you make all the discussions about how urgent you need something, they said, well, okay, you get it, because now that goes faster than hearing all the arguments that you are giving. Okay, and then I would not forget you're very social. I like you as a guy very much, all the people in the group do the same, and also Philips, you make a very good impression. And you also integrate very easily in the group. All very important aspects aside, the technical aspects, which are also good. So now it's time, I want to hand over you the diploma and to congratulate this very good results. And I really want you to say that I hope that you will have a very, very good career. And I want to ask you to keep us informed if you take a job and where you're going, and if you change jobs, that you keep track of you. Yeah? So now it's time.